Hi, I'm Alex Heneveld, CTO at Cloudsoft. I'm here to tell you about Cloudsoft AMP. This is our flagship product, which lets you control and manage and model your applications. It builds on your infrastructure as code, but solves a lot of the challenges people face in managing the complexity, where there are a lot of systems to bring together. It's aimed at SRE teams, DevOps teams, platform teams, application teams, anyone who needs to deal with the integration of multiple systems in order to keep their system operating well. The key concepts, which you'll see, are to first model the topology of the application. So we're not a flat laundry list of cloud resources, but you're understanding the application's topology, the architecture, when you're managing it and when you're attaching the other three key concepts. And those other three key concepts are the sensors, which let AMP know what's happening at each of the components. Now, these might be infrastructure pieces, or they might be groupings of those higher up in the tree corresponding to topological components. And they can come from any and all of your monitoring tools: CloudWatch, Prometheus, Dynatrace, AppDynamics, or logging, Splunk, or from your applications themselves by making REST calls. You can also attach the operations, the effectors, to any of these components, all of it described as code alongside, for instance, your Terraform. And these effectors can invoke bash scripts, run Ansible playbooks, call to REST endpoints, run containers, whatever you need done. They can also update the model, which becomes very important when you're dealing with dynamic environments. Finally, tying them together are the policies, which again attach to any of the components in the topology. As you'll see, they can be triggered by sensors with conditions and or periodically, and then can run your effectors to make sure that recovery happens when it needs to, that optimizations or backups happen at certain times, with the result that you can easily automate away a lot of the toil that keeps developers and engineers busy, prevents them from doing the interesting tasks, and also ensure resilience is coded up, that applications fix themselves. Our background is autonomics, and those of you familiar with autonomic computing will see that this is an autonomic system, where one of the core ideas is to compose smarts into subsystems that look after themselves. But higher up in the tree, we can lean on the topology to take more coordinated recovery action. That's enough waffle. Let's flip to the demo. If we come in here, one of the ways to get started is to take your existing Terraform configurations and or deployments. I don't have anything yet, but I do have a Terraform application sitting here ready to go. It's deployed, so all we need to do is mz init. And it has recognized that we are using Terraform, and we can start it. However, we do want to give it a better name. So let's call it Node with Dynamo. And we'll say yes. And at this point, it is updating our configuration and state from Terraform to the server, running some validation. And it's detected that the application is deployed and ready to go. If we click in here, we see the combined view of the individual elements in our Terraform configuration, along with the current state, things like the IP address for the server. And we can drill in and look at all of the attributes. We can even look at the source code for individual pieces. This is just getting started. The first thing that we'll want to do is represent the topology. And we do that with the editor. And let's, this is a fairly simple 3-tier app. We've got a front-end tier with our node server, the key pair for it. And we can, for instance, have a data tier sitting here. And I can move some of the data tier elements in. Let's save that. We won't do it all here because a lot of the ways people like to work is from the command line. So there's seamless integration with the usual Terraform workflows. So I flip back to the command line and sync. it's pulled down my changes. You see here, it's added one new file, main.mz, which we can take a look at. And in essentially Terraform syntax, HCL, we've described the two new Maestro resources we've added. Maestro is the Terraform subsystem of AMP. We've got one for our front end and one for our data tier. The other things that we're doing are extending the existing Terraform resources, and simply in this case, saying what the parent is. Now we'll do a little bit more. Let me copy in. Copy in the full grouping. And I can sync it back to the server. Everything sits in a unapplied state. And we now see that we've got it grouped the way that we wanted. But I can then apply these changes, and I can do that at the server or in the client. And we're now up and running with the right model. The next step is to add sensors. So let's show how that works. I will apply it, and then I will show you exactly what's happened when we did this. And if we take a look, for instance, at the Node.js server, all of the Maestro modeling is in sidecar MZ files, so it doesn't interfere with your Terraform. But in that resource block, we've now added a very simple sensor and widget block. The sensor tells us what we want to show. In this case, we're doing nothing more than Terraform interpolation of the variables to produce a URL. And displaying it. Slightly more interesting, down here at the node server, we're computing latency by making a simple web request. We could also call a container or a script or SSH, doing that periodically and returning the duration. So here on the left, we see our URL and we see our latency, and we can click through. And we have our application, which we deployed, working against a Dynamo resource and a traditional VM. Now, this application has a little bug, which in this short demo we won't fix, but love to show you a longer one. As we make more and more requests, latency climbs up. So we fix that, of course, with the effectors and sensors. I will just jump to that. And in this one, we have added, for instance, to our Node.js server, not just the sensors, but an effector, which most part SSHs and runs a restart script. Similar things are happening here, using a container to call AWS to clear out some of the records in the data table. And there's a policy which says to do that whenever the latency gets high. So as soon as we apply this, we will see that we have our effector over here. We can manually restart the server, but the policy's kicked in and done it automatically. That server's been restarted and the data table has cleaned it out back down to 6 records. Going under the covers, you have all the information about what has happened here. So if you need to get a deep dive to whatever any of your systems are doing, or the root cause analysis, why did certain things happen? AMP is a central pane of glass. It's not trying to replace the other systems, but make it easy to jump out and get to the right place in lots of systems, or have the right data with the right context as part of your model, so that the engineers can concentrate on providing the automation, resilience, and compliance as code in a way that fits seamlessly into how people like to use Terraform and develop. We'd love to show you more, so please get in touch. Let us know how this interests you. Thank you.